Welcome to a deep dive into the world of deep reinforcement learning in medical imaging.
Oh, it's going to be an exciting one.
It is DRL. We'll just call it that for short.
Yeah.
And we've got a fascinating paper to kind of unpack today
We do.
from Medical Image Analysis Journal, authored by Zhu and colleagues in 2021.
It's a really interesting paper. I think people are going to find it really cool how this is all coming together.
Yeah, when I first heard about DRL, I immediately pictured like a dog, learning tricks. You reward them for the right actions and they eventually figure it out
Yeah.
how to do these really complex tasks.
Mhm.
Turns out that's not too far off.
That's a great comparison.
Is it?
Yeah, in DRL we have what we call an agent,
Okay.
which is essentially our algorithm interacting with an environment.
Okay.
And that environment, in the case of medical imaging, is the image itself.
Right.
So the agent takes actions within this environment and receives rewards for making good decisions and penalties for bad ones.
So if you're trying to pinpoint a specific vertebra
Yeah.
in a 3D spine scan, each step closer to the vertebra earns a reward, and moving away results in a penalty.
That's a perfect example.
Okay.
And through this trial and error process, the agent learns a strategy, or what I call a policy, for maximizing its rewards. And there are different ways the agent can learn.
Oh, really?
It can learn from pure experience, what we call model-free learning,
Okay.
or it can use a model of the environment, what we call model-based learning.
So model-based is like having a cheat sheet.
Exactly like having a physics textbook to understand how things work.
But would creating those models be really challenging?
You've hit a very key point.
That way.
Model-based learning can be more efficient,
Right.
but building those models for intricate medical scenarios can be tricky.
Okay, so I'm starting to grasp the basics.
Yeah.
But why is DRL so well suited for medical imaging?
Well, one key advantage is how DRL handles these enormous medical images,
Yeah.
especially 3D ones, instead of analyzing the entire image at once, which can be computationally very expensive. The DRL agent analyzes small regions sequentially.
So it's like focusing on one area of a puzzle at a time instead of trying to do the whole thing at once.
Precisely.
That seems much more efficient.
It is, and this sequential processing makes DRL incredibly efficient for large medical images, and what's even cooler, it can tackle tasks where success isn't easily measured with a simple number.
So like what?
Well, think of fine-tuning a cancer treatment plan where multiple factors contribute to the optimal outcome.
Ah, okay.
Those are the situations where DRL really shines.
So DRL is not just about speed and efficiency.
Right.
It's also about handling complexity and nuance.
Absolutely. And you know what's even more intriguing is that this sequential processing actually mirrors how our own eyes scan a scene.
Oh, really?
We focus on specific points of interest rather than trying to absorb everything at once.
So it's more intuitive and closer to how humans analyze images.
Yeah.
Now, I'm really curious about the ways DRL is being applied in medical imaging.
Mm-hmm.
What are some of the tasks that it's already tackling?
Let's start with landmark detection. Remember our example of pinpointing a vertebra in a spine scan?
Yeah, that really helped me understand the whole agent environment reward thing.
Exactly. It's a fundamental task in many medical imaging workflows, and Zhu's paper highlights some incredible research by Gusu and his team.
Okay.
They developed a DRL agent that could automatically locate 49 different anatomical landmarks in 3D CT scans.
Wow.
And they tested it on a data set of over 5,000 scans.
No,
The results were astounding.
don't keep me in suspense. How astounding.
The agent achieved perfect accuracy.
Perfect accuracy.
Yeah.
So no more tedious manual annotation by clinicians, which could be a huge time sink for them.
Huge time sink.
This frees up more time for patient care.
Exactly.
This is truly groundbreaking stuff.
It is, and it's just the beginning. Landmark detection is just one piece of the puzzle.
All right, you've got my attention. What other pieces are there?
Another important application is image registration. So think about having a CT scan and an MRI scan of the same patient. Image registration is the process of precisely aligning those images so you can get a more complete picture of their anatomy.
Ah, so like creating a composite image that combines the best of both worlds.
You got it. And DRL can automate this process even for complex cases where the images have different shapes or distortions.
So instead of spending hours manually aligning these images, a clinician could rely on DRL to handle this task quickly and accurately.
Yeah.
What about detecting lesions or abnormalities? Is DRL being used for that?
Absolutely. One study showcased a DRL agent that learned to detect breast lesions from DCE MRI scans,
Oh, wow.
achieving similar accuracy to the best existing methods, but with much faster detection times.
Faster detection could be crucial for early diagnosis and intervention, potentially improving patient outcomes.
Yeah,
It seems DRL is truly pushing the boundaries of what's possible in medical imaging.
it is, and there are many other fascinating applications emerging.
Like what?
Well, for instance, think of those standard cross-sectional views you see in medical textbooks, axial, sagittal, coronal. Well, DRL can learn to automatically find those standard viewing planes in 3D medical volumes.
So no more manual scrolling through a 3D volume to find the right view. That
Exactly.
could significantly streamline image interpretation.
It could, and also potentially aid in diagnosis by ensuring clinicians are looking at the most relevant views right from the start.
Makes sense, but that's not all, is it?
That's not all. DRL is also being explored for optimizing various aspects of medical image analysis.
Like what kind of optimizations are we talking about?
Well, we've already touched on radiotherapy planning,
Right.
but there's so much more. DRL can learn to select the best image augmentations to improve image classification, which is like giving the algorithm extra training data to improve its performance.
Okay, that's clever. What else?
It can also optimize CT scan trajectories to reduce artifacts, which are those annoying distortions that can sometimes obscure important details in the image.
Right.
And get this, DRL can even personalize CT scans.
Personalized scans. What does that even mean?
It means tailoring the scan parameters to each individual patient to maximize image quality while minimizing radiation dose.
Wow, that's truly amazing. It sounds like DRL is already making significant strides in medical imaging, but I imagine there's still some hurdles to overcome, right?
Oh, yeah, of course. With every new technology, there are always challenges, but we're working on them.
What are some of the hurdles facing DRL in medical imaging, even with all this progress?
Well, one challenge we touched upon earlier is defining the right reward for the DRL agent.
Right.
It's not always easy to translate those complex medical goals into a simple reward signal that guides the agent's learning.
So it's more than just like find the landmark or detect the lesion.
Right.
There are nuances to what makes a good outcome in medicine.
Precisely. And even when we can define a good reward, we have to watch out for unintended consequences. For example, if we reward an agent for detecting lesions, it might become overly sensitive and start flagging harmless variations as potential problems.
I see. It's like setting your spam filter to be too aggressive.
Yeah.
It might catch all the junk mail,
Right.
but then you risk missing important messages.
That's a great analogy. We need to find that sweet spot between sensitivity and specificity.
Okay, so designing the right rewards is a big challenge.
Yeah.
What else?
Another challenge is the need for large data sets to train these DRL agents.
Right.
Medical data can be hard to come by, especially when you need labeled data for supervised learning.
Yeah, you need those expert annotations to tell the agent what's what.
Exactly.
But I've heard about techniques like transfer learning that might help address this data scarcity issue. Can you tell us more about that?
Absolutely. Transfer learning is a powerful technique where we take a DRL agent that's been pre-trained on a large data set, maybe from a different domain, and then fine-tune it on a smaller, more specialized data set.
So it's like giving the agent a head start.
Exactly.
It doesn't have to start from scratch every time.
Right. And this can be a game changer for medical imaging, where collecting massive amounts of labeled data can be difficult and time-consuming.
Yeah. So it sounds like transfer learning could really accelerate the development and deployment of DRL in clinical settings. But I can't help but think about the broader implications of having AI involved in medical decision-making.
Sure.
Are there ethical considerations we need to be mindful of?
You raise a really important point. As with any powerful technology, we need to proceed thoughtfully and responsibly.
Right. It's not just about what we can do.
Well,
It's about what we should do.
exactly. We need to ensure that these DRL agents are used to augment and assist clinicians, not replace them.
Right.
Human judgment and empathy
Yeah.
remain essential in healthcare.
I completely agree. The human touch should never be lost in the pursuit of technological advancements. It sounds like we need a collaborative approach,
I think so.
with DRL serving as a powerful tool in the hands of skilled clinicians.
Absolutely. A partnership between human expertise and artificial intelligence.
Okay, so we've covered some of the challenges and ethical considerations.
Right.
Now I'm eager to kind of dive back into those exciting future directions you mentioned earlier. Let's start with inverse reinforcement learning,
Okay.
IRL.
IRL.
You described it as a way to learn from expert demonstrations.
That's right. Remember our analogy of the apprentice learning from the master craftsman?
Yeah.
Well, IRL allows the DRL agent to learn by observing how human experts perform a task rather than relying on explicitly defined rewards.
So instead of trying to program the rules for interpreting a complex medical image,
Yeah,
we can simply show the DRL agent examples of how experienced radiologists do it.
precisely. And this could be incredibly valuable for tasks that are difficult to formalize or articulate, where human intuition and experience play a crucial role.
So IRL seems like a powerful way to bridge the gap between human expertise and machine learning, potentially leading to more robust and reliable AI tools.
Absolutely.
What about multi-agent DRL? How could that advance the field?
Multi-agent DRL opens up some really fascinating possibilities for collaboration and specialization.
Okay.
Imagine a team of DRL agents, each trained on a specific organ or disease, working together to analyze a patient's medical images.
So instead of having like one general-purpose DRL agent,
Right.
we could have a team of specialists, each bringing their own unique knowledge to the table.
Yeah, like having a virtual tumor board,
Yeah,
but with AI experts.
that's a great analogy. And these agents could not only analyze images independently, but also communicate and share information with each other, leading to a more comprehensive and nuanced understanding of the patient's condition.
Yeah, exactly.
That sounds like a powerful way to leverage the strengths of different DRL agents, combining their expertise to achieve a common goal.
Now, what about that last future direction you mentioned, meta learning?
Yeah, meta learning is all about teaching DRL agents to learn how to learn.
Okay.
It's like giving them the ability to adapt quickly to new tasks or new types of medical images without requiring massive amounts of training data each time.
So it's about creating DRL agents that are more versatile and adaptable,
Exactly.
able to handle the ever-evolving landscape of medical imaging. Right, think about the sheer diversity of medical imaging modalities out there. X-ray, CT, scans, MRI, ultrasound, and so on. Each modality produces different types of images, requiring specialized algorithms for analysis. Meta-learning could help us develop DRL agents that can quickly adapt to these different modalities and even learn from new ones as they emerge.
That would be a game changer.
You would!
No more needing to train separate DRL agents for each specific task or imaging modality.
Exactly. Meta-learning could unlock a whole new level of flexibility and efficiency in medical imaging AI, allowing us to tackle a wider range of challenges with fewer resources.
This deep dive has been an incredible journey so far.
Yeah, it has.
We've explored the fundamentals of DRL, its impressive applications in medical imaging, and the ethical considerations we need to keep in mind. And now we've glimpsed the exciting possibilities of inverse reinforcement learning, multi-agent DRL, and meta-learning.
We have, and it's clear this technology really has the power to reshape medicine in profound ways.
Yeah.
But there's one more intriguing area to explore.
Oh, you've piqued my curiosity again. What else is there?
Well, so far we've focused on DRL's role in analyzing medical images.
Right.
But what if we could use DRL to go beyond just diagnostics and into the realm of intervention, influencing actions, and shaping entire healthcare journeys?
So we're going beyond simply analyzing images
Yeah,
and moving into the realm of actually guiding actions and decisions in healthcare.
that's right. Imagine DRL helping us personalize not just medical scans,
Right.
but entire healthcare journeys. Think of all the choices made throughout a treatment plan,
Yeah.
medications, lifestyle changes, timing of procedures. Each decision is like a step in a complex game, and the outcome depends on so many factors.
So you're saying DRL could help navigate these complex healthcare journeys,
Yeah,
optimizing each decision along the way for the best possible results.
exactly. By analyzing vast amounts of patient data, DRL could learn personalized treatment strategies, finding patterns and insights that might not be obvious to human clinicians.
That sounds incredibly powerful, but also raises some concerns. Wouldn't this require access to very sensitive personal health information?
Yeah.
How do we balance those potential benefits with the need for privacy?
You've hit on a crucial point.
Have I?
We absolutely need robust frameworks for data security and privacy protection, ensuring that any use of patient information is responsible and ethical. One promising avenue is federated learning.
Federated learning.
Yeah.
I haven't heard of that.
It's a technique where DRL models are trained on data that stays distributed across multiple institutions or even individual devices. So instead of pooling all the data in one central location,
Right.
the learning happens locally, preserving privacy while still allowing us to leverage the power of large data sets.
So it's like having the algorithm travel to the data instead of the data traveling to the algorithms.
Exactly.
That's a clever way to address the privacy concerns.
It is, and there are already some real-world examples of this kind of personalized healthcare intervention
Yeah.
using DRL. There's a study mentioned in the paper where DRL was used to personalize mobile health interventions.
Oh.
Picture a smartphone app that uses DRL to analyze your activity data, your sleep patterns, even social interactions, and then provides tailored advice and support for managing a condition like diabetes or heart disease.
It's like having a virtual health coach in your pocket, constantly learning and adapting to your individual needs. It's amazing to think how DRL could personalize healthcare on such a granular level.
And that's just the beginning. As DRL continues to advance, we can imagine even more sophisticated applications in areas like personalized drug discovery, robotic surgery, even mental health care.
This has been an absolutely mind-blowing deep dive.
It has.
We started with the fundamentals of DRL and its amazing applications in medical image analysis, then ventured into the ethical considerations and this incredible potential for DRL to optimize complex healthcare journeys. This technology truly has the power to reshape medicine in profound ways.
It's been a fascinating journey exploring the landscape of DRL and witnessing its potential to analyze, optimize, and personalize healthcare. But remember, the true potential lies not just in the algorithms themselves, but in our ability to use them wisely and ethically.
It's a reminder that technology is a tool, and it's up to us to guide its development and ensure it ultimately benefits humanity.
Exactly. The future of healthcare is being shaped by these incredible advances in AI, and it's a future we all have a stake in shaping.
Well, listeners, we've reached the end of our deep dive into deep reinforcement learning. In medical imaging, we've covered a lot of ground from the basics to the mind-blowing possibilities, and hopefully you've come away with a sense of excitement and wonder about the potential of this technology.
And a sense of responsibility, too. We encourage you to explore the source material, further ponder the potential of DRL, and engage in the ongoing conversations about its ethical development and application. The journey of discovery is just beginning.
Thanks for joining us on this deep dive. Until next time, keep exploring, keep learning, and keep asking those big questions.